What's up, you absolutely wonderful Magento loving friends of mine? It's time for your weekly dose of a practice test question answer. Before we jump in, though, I'd like to quickly walk through two announcements that I have that I think you will find quite interesting. At least I hope you do. First one is tomorrow, June 3rd at 11 a.m. in the morning Eastern Time. We're going to have our Certification Challenge Award ceremony. And boy, this is going to be a special time where we recognize those people who have achieved certifications. I hope you'll be able to join us to be able to make it to this very special event. Secondly, I am speaking at the Magento Association Connect here next Tuesday, June 7th. I'm also going to be in the UK June 21st. For the Meet Magento UK, I will be also speaking there. So Meet Magento, the Magento Association Connect next Tuesday. I'd love to be able to hang out with some of you all there. It's going to be virtual, so it's not quite like being in person, like it will be here June 21st, Meet Magento UK. And I hope you'll be able to make it. I know tickets are selling out fast, so make sure you get signed up there as quickly as possible if you are going to be able to make it. Without further ado, let's jump into the question. You are architecting a processing framework to work with an order at its three stages: quote, sales order, and invoice. Each stage processor implements both a common service contract as well as unique service contracts for each stage to reduce tight coupling. The first step is initializing each object. Keeping maintainability in mind, how do you design this solution? Well, we have a couple options here. Let's take a look at these answers. I have the correct answer selected, so let's take a look. Create a custom factory to accept the order object and return the applicable class using Object Manager. B, establish a constant map to identify which object to initialize based off of the order object's type and use Object Manager to initialize. C, use dependency injection to inject each stage processor and then select and return the correct one. So there is this is a what I would put into the category of a somewhat tricky question. And the semantics of this one are really important. So let's look at each one of these and see why it would be the right answer or the wrong answer. And obviously, you've already seen I have selected A as the correct answer, but let's investigate what's going on here. So create a custom factory to accept the order object and return the applicable class using Object Manager. So this is specifically talking about the factory design pattern. You probably are familiar with this. Magento automatically creates a factory for every class that has been where the factory addendum to the class name has been injected, and the result is a class. The factory class is added to that same path, but in the generated directory. This works fine. However, there is nothing wrong with creating your own factory. In fact, I've done this not as much recently, but in the past, depending on the project, the situation, I've done this fairly regularly. Take a look at this code here. What I did was I literally went in and I, not that one. Let's see, I thought I had it pulled up here. Perhaps I lost it. I guess I did. So I literally went into the generated directory and code, just literally pick anything. This probably has one. Yeah, here's a roll factory. I went and literally copied this out, but in doing so, we get to understand exactly what is happening with this factory. So we, instead of just saying, oh, a factory exists in the generated directory, no, we actually can use this ourselves. This is code that's created and again is usable. So looking at this, we have our object managers, which is injected. And historically speaking, we should never, ever touch the object manager in any of our code. And this is one of those few exceptions. To the best of my memory, it actually is listed in DevDocs as a reasonable exception. We are creating our own factory. So it's not, so this is explicitly, a factory is explicitly allowed to work with a given, a factory is allowed to work with the object manager, right? So we inject the object manager, or Magento is injecting the object manager and an instance type. Well, I literally copied this out, our create method, etc. I created a class called stage factory, and we have a create. We are passing this object type in here, and I have type into the three types of objects that we would allow. We map the type over here, which is kind of is a bit of a look at our second option here, B. There's kind of some carryover here, but it does not specifically reference a custom factory. So ultimately, B could be like anywhere. And when I say keeping maintainability in mind, seeing the word factory in a class name immediately is more maintainable because we know what this object is doing. So in this case, we are passing in this object, card interface, invoice interface, order interface, whatever. And ultimately, was it PHP 8.1? I think we can actually force these as multiple, as like a union of type hints. We can, so we have we're basically iterating through. I have this map. So we have, this is the Magento classes or Magento service contracts. This is going to map over to our own service contracts. And we use this method right here to make that mapping happen. And then ultimately, if we do have a type, or if we don't have a type, we're going to throw an error. If we do have a type, then we return this type that was mapped out, as well as the data that was passed along in, which is not required, right? We can just pass it in empty or default array. And actually, let me back up from even here. The way the structure that I was seeing when I wrote this question here is we have several service contracts. We have a stage processor interface, which we have guaranteed that our stage factory returns. So actually, I did not do that. So this should be a stage processor interface. We are guaranteeing that this is going to run a stage or return a stage processor interface. However, beyond that, we could be returning an order stage interface, etc. And the way I designed this and foresaw this implementation is these are all separate. So they could extend stage processor interface, which I don't think there's anything wrong with that. But typically speaking, abstraction is not necessarily ideal. So this more or less is a tag to say, okay, this is in use for like dependency injection preferences. As you see, I have mapped out right here for invoice stage interface. It's basically a tag, but each one of these at this point, they don't declare any additional methods. In the future, yeah, they definitely could, but at this point they don't. It's just more of tagging this class. So this is why I chose answer A as being the best answer. Again, keeping maintainability in mind, simply because we can create our own factory. It's easy to create our own factory. Just begin copying stuff around, and the result is this is a highly extensible solution. Now, to prove this, and this is where I harp on integration tests. I love integration tests. I wrote an integration test here to prove that this works. Basically, what this does is we are loading in a Magento data fixture for an order, and there is fixtures for invoices. There's fixtures for quotes. We have our list of items that we are loading in via the order repository and the search criteria builder, because unfortunately, the order repository you cannot load based off increment ID, and the data fixture creates based off the increment ID. So then we fetch the first item and we create this result, and we basically are asserting that the output is an instance of order stage interface. Piece of cake. So that's why I do it like this. It's tested. This is a stable, very stable solution that, in my opinion, is highly maintainable. So let's jump back and look at these other answers. And ultimately, the key point is here, why are these other answers inferior to A? B, establish a concept map, which we actually did, to identify which object to initialize based off of the order objects type, and use Object Manager to initialize. This is basically what we are doing. However, we are not using a custom factory. So again, this could be anywhere. And by virtue of the custom factory, putting that design pattern principle in here, I feel like B is inferior for that very reason. Now, C, using dependency injection to inject each stage processor and then select and return the correct one. So in this case, we have the way I see this is we would have a class, and this is why there was a lot of you that chose this answer, which on the surface can seem quite reasonable. So we would create a class somewhat similar to this. So we'd create a new file. Let's see here. Single class demo. Let's just do something like this. And then namespace SwiftOtter. At the end of the day, this can work similar. So we would say get. We would have our order coming in here. function construct, and then we would load in, let's see here, invoice stage interface, invoice stage. Let's see here, that would be order stage interface, etc. And I won't build all this out, just to get so that you get the idea. And then of course we need to initialize our properties, and then we would say basically, and here's where this is less maintainable. If order instance of invoice stage interface return, but you see where this is breaking down, because we would have to then do the factory. So we can change this out to a factory. Well, that's fine. We can change this out to invoice stage interface factory. Let's see, we'll duplicate this. And actually, let's clean this all out again so we can regenerate these values. We'll add factory here. Oopsie. Big text on a small screen always is a little interesting. Factory. And then we'll reinitialize these properties. Bingo. All right, making progress here, folks. So then we would do this, invoice stage factory, create, etc. And actually, as I'm thinking about this, going back on this, so this is these classes were not designed to, well, actually, yes, they were designed. So it depends on how, I'm actually getting a little fuzzy as far as how I meant to design this, whether the class should have a class variable or not, etc. So either way, we've covered it from that perspective. The one final thing is to note, and one improvement, as I was saying this earlier, that we also can do, is this map could and should be moved into DIXML. And the way we would do this is we would have an array map, which would look something like this, initialize properties, and we would copy this over into our DIXML. Type name, name is SwiftOtter teaching. Let's see here, that was model stage factory. Arguments, argument name is map, XSI type is array, item name is, and this is where we would copy this over. So this would be the name, and then XSI type is string. And we would drop this in there. So you could argue whether this is, better or worse. Ultimately, we have control over this in DIXML. So ultimately, it's very easy for other classes. Like if we're building a third-party module to distribute, other classes could get in and easily add to this or modify this. So that's a huge value add for third-party. A little bit less if you're just doing this, in your own application, that sort of thing. But yeah, so this is, I feel like in pretty much every way, the stage factory has significant benefits for maintainability. And so that's why I chose the answer. I hope this was enlightening. I hope this was helpful for you. If you don't find it helpful or enlightening, please let me know, because I love to have these conversations. I love to debate, have good debates. And as always, you might get it just to earn a ticket to a presence on Smash the Bug. Talk to you later. Have a good, wonderful week.